بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتطرق للدرس الأول في مادة الديناميكا، وهو اسمه تفاضل الدوال المتجهة. طبعا احنا عارفين في فرق شاسع بين علم الديناميكا وعلم الاستاتيكا. علم الديناميك وهو علم الحركة، أما علم الاستاتيكا هو علم السكون. أول درس في علم الديناميكا عندنا في المنهج ثالثة ثانوي اسمه differentiation of vector function، أي تفاضل الدوال المتجهة. Welcome my dear student in our math program for second 3. Today we are taking the first lesson in dynamic. It's called differentiation of vector function. My dear student, look at about differentiation of vector function. My dear student, rectilinear motion. What is the meaning of rectilinear motion? If particle moves in straight line, it is moves in a linear motion. If particle moves in straight line, it is moves in a linear motion. What is the meaning of position of particle? Position of particle, my dear student, when particle moves in a linear motion, at this moment it takes up a certain position on straight line. To identify the position of x for a moving particle at any moment t, we choose constant point O on a straight line as an origin point and determine the positive direction along the line. We choose, my dear student, constant point O on a straight line as an origin point and determine the position direction along the line. My dear student, look at important example. Look at, my dear student, if we have OA or particle is at position A on the straight line. We have particle, its position point A on straight line. Look at, my dear student, x vector equal 5c vector. C vector direction vector of OA vector. C vector means direction vector of OA vector. X vector equals 5 unit in C vector. C is unit vector on direction OA vector. Note that, my dear student, at the first, the position of the particle is a vector quantity and it can be expressed as a function of the time t. Position of the particle is a vector quantity and it can be expressed as a function of time t. What you note, look at x vector equals function of t as x vector equals f of t, function of t. T is time. Displacement. Displacement is known as a change of its position. Look at, my dear student, S vector represent displacement equals delta x. Delta x, change of the position of vector, means x dash vector minus x vector. Delta x is the positive when A dash more than E, or delta x is positive when x dash more than x. What you mean? A dash represent x dash vector, A represent x vector. Then delta x is positive when A dash more than A, or A dash is far from A or more than distant of A. Velocity. What is the meaning of the velocity, my dear student? If, my dear student, S vector displacement equals delta x is displacement of the particle during of the time delta t, then average velocity v a vector is equal quotient of displacement over time. What do you mean average velocity, my dear student? Quotient of displacement over time, or delta S over delta T. Look at average velocity delta X or delta S over delta T. My dear student, remember delta X or delta S represent displacement, delta T respect to time. This rule, delta X over delta T, we can express by using X bracket T plus delta T minus XT over delta T. Change of displacement X vector of T plus delta T minus XT over delta T is called or denoted by average velocity. Then, my dear student, average velocity equals limit when delta t tends to 0, delta x over delta t. Change of displacement respect to time. Then, average velocity v a vector equals limit when delta t tends to 0, delta x over delta t, equals by substitution v a vector equals limit delta t tends to 0, x t plus delta t minus xt over delta t. This average velocity. Therefore, average velocity dx over dt, or differentiation of the position factor respect to the time t. This is called average velocity. Or the slope of the tangent to the curve of position time. My dear student, delta x over delta t means the slope of the tangent to the curve of position time. Speed. What is the difference between speed and velocity? My dear student, speed is Vt is the velocity vector of the body moving in a straight line. The speed is standard quantity expressed the magnitude of the velocity vector. My dear student, the speed is standard quantity expressing as magnitude of the velocity vector. My dear student, we can express about v norm velocity denoted the speed. Speed norm v equals norm dx over dt, or equals norm ds over dt. What do you mean of the norm? My dear student, norm is the number of the speed equals norm ds over dt. The speed is algebraic measure of velocity vector and x algebraic measure of position. Look at, my dear student, the first example. A stone is projected vertically upwards and its height x after t seconds. From the projection is given by the relation x equals 49t minus 4.9 t square, where x is in meters. What is the required? Find maximum height the projected body can reach. Find the maximum height the projected body can reach. This is number A. Number B, find algebraic of the velocity vector when the stone is 78.4 meters height, then find its velocity. Number C, graph both the position time graph and use them to analyze the motion. My dear student, look at the solution. My dear student, xt from given equals 49t minus 4.9 t square. What is the velocity? Excellent student. Differentiation of the position vector respect time t. If we have x vector equals 49t minus 4.9 t square, what is the velocity? We find differentiation this position vector respect to time t equals what? 49 minus 9.8 t. This is differentiation of x respect to time t. The stone reach the maximum height when x uncertain, velocity equals 0. My dear student, if we projected any body to maximum height, means velocity in this moment equals 0. Therefore, 49 minus 8.8 t equals 0 from given. Find the value of t equals 5 seconds. Maximum height is t equal 5. We substitution about t equal 5, maximum height equal 49 times 5 minus 4.9 multiply 5 square. Answer is 122.5 meters. My dear student, maximum height 122.5 meter. In this height, velocity equals what? X student, velocity equals 0. Why? Because when a body reach to maximum height, must velocity equals 0. After that, number B, when the stone is 78.4 meters high, when x equal 78.4, substitution about x equals 78.4. Therefore, 49t minus 4.9 t square equals 78.4. This is equation of second degree. By using factorization or calculators, find the value of t. To find the value of t, by using divided by 4.9, therefore t square minus 10t plus 16 equals 0. By using factorization, t minus 8 inside bracket multiply t minus 2 inside bracket also equals 0. Therefore, in this case t equals 8 or t equals what? T equals 2. What do you mean my dear student? We have two times the first t equals 8, the second t equals 2. When find the velocity when t equals 2, by substitution about t equal 2, answer is 29.4 meter per second. The velocity of the body when t equals 2. But when t equals 8, velocity equals 49 minus 9.8 times 8 equals 29.4. My dear student, the stone is 78.4 meters once ascending after 2 seconds and once descending after 8 seconds. My dear student, we have two times, t equals 2, t equals 8. What you mean? The stone is 78.4 meter once ascending after 2 seconds, and once descending after 8 seconds. Algebraic measure of the velocity equals 29.4 or negative 29.4, the velocity of the stone in the two cases. Positive or negative, norm 29.4. This algebraic measure, we find the norm or the length equal positive 29.4 meter per second. This is the velocity of a stone in two cases. From the position time graph, we find that, my dear student, look at the position time graph. In x-axis or horizontal axis, we put t time, vertical axis xt or position vector. Look at position vector in vertical line and t time horizontal line. After that, look at, my dear students, the curve which represent when t equals 2, when t equals 5, when t equals 8. Look at, my dear student, the stone reaches the maximum height. What is the maximum height? 122.5 meter. Maximum height means velocity equals what? Equals 0. T equals 5 when the stone reaches the maximum height. Look at the maximum height when t equals 5. When t equals 5, in the opposite graph, the height is 122.5 meter. The stone gets back to projection point once again when t equals what? T equals 10. When after t equals 10, the stone gets back to the projection point once. My dear student, if we projected the stone at the first t equals 0, after 10 seconds, the stone gets back to projection point and reaches 122.5 when t equals what? T equals 5. The ascending stage took 5 seconds and descending stage took another 5 seconds. Ascending and descending. The stone was at 78.4 meter height when t equals what? T equals 2. Look at, when t equals 2, the stone was at 78.4 meter height. And when t equals 8. My dear student, the stone was at 78.4 when time equals 2 and when time equals 8. How? When time is 2 in ascending, the projected, my dear student, when project the stone in ascending, when t equals 2, the stone reach 78.4 and get back the stone once get back when t equals 8, the stone still 78.4 meter. From the velocity time graph, we find that, look at velocity vertical line, t horizontal line. My dear student, t equals 1, 2, 3, 4, 5, 6, and so on to 10. V velocity positive up 0, negative down 0. Look at, my dear student, the line which represent velocity time graph. When t equals 0, velocity is 49. When t equals 5, velocity equals 0. My dear student, look at the initial or starting velocity of the stone when t equals 0. The velocity is 49 meters per second and gets to decrease during to the time interval, close the interval 0, 5. Until the stone got instantly static when t equals 5, when the stone reaches its maximum height. Then velocity increases in maximum height equals what? Area of triangle OAL. Area of triangle under the line and XY axis equal area of triangle equal half base times height. Half times 5, height 49 equals 122.5 meter square. This area of triangle. Now we are translate to another title. It's called acceleration. My dear student, what you mean of acceleration? F dv delta v expresses the change of the velocity vector during time interval delta t. Look at, my dear student, acceleration, its symbol a. Delta v expresses the change of the velocity vector during the interval delta t. Then the average acceleration a vector is given by the relation. What is the relation? A vector delta v over delta t, change of velocity respect to time, or equals limit when delta t tends to 0, v t plus delta t inside bracket minus vt over delta t, change of the velocity respect to time. This is acceleration. My dear student, look at acceleration delta v over delta t. Acceleration we can put in another form, dv over dt, differentiation of the velocity respect to time, is the rate of change of the velocity vector with respect to the time t, or slope of the tangent to the velocity time graph. Slope of the tangent of the velocity of time graph is called acceleration. V vector equals dx vector over delta t. Therefore, acceleration A equal dv over dt or d2x vector over del dt square. What you mean d2? We find the first derivative and find the second derivative of position vector x respect to the time t. My dear student, note that we have two velocity at 2 point or 2 particle a at a v1 v2. A more than 0, acceleration more than 0, then v increases. This means that particle speed up in the positive direction. Look at, my dear student, at point A, v1, v2 in same direction. A more than 0, change of the velocity more than 0. Look at, my dear student, we have v1, v2, v1 at A, v2 at B. A smaller than 0, then we deduce that v velocity decreases. This means that particle speed down in the positive direction, or particle speed up in negative direction. My dear student, by the end of the lesson, we know that what is the difference between speed and velocity? What is the distance? What is the difference between displacement and distance? And we know that meaning of acceleration, derivative of velocity respect to time, but the velocity means change of displacement respect to the time. This lesson is very important to my lesson or my science, dynamic science. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.